Hello everyone, myself Paul Mohan, Assistant Professor of EC Department at LJ Institute of Engineering and Technology. Welcome to the session of Radar and Navigation Aids. So, in this subject, we are going to study total 12 chapters starting from the introduction. In this introduction, we will study the advantages, disadvantages of RNA, what is the definition of radar, and what are the applications of radar. Second, the radar equation. So in this radar equation, chapter number 2, we will study the radar range equation. What are the parameters that affect the radar range, and what is radar range? The most important question. That is derivation of radar range equation. Unit number 3, that is continuous wave and FMCW radar. So in this chapter number 3, we are going to study different types of radar like continuous wave radar, pulse radar, frequency modulated continuous wave radar, airborne radar, like this. In unit number 4, we will study the moving target indicator, real and concealer, pulse Doppler radar, how to detect the moving target in presence of fixed target, how to reduce the effect of the clutter, right? So in this chapter number 4, we will study the MPI and the pulse Doppler radar and the comparison between it. Chapter number 5, that is tracking and imaging radar. So how to track the target? Like tracking can be done in the 4 ways. It can be azimuth angle, elevation angle, range, and the Doppler shift frequency, right? So in chapter number 5, we will study how to track any target in presence of fixed target. Chapter number 6, we will going to study the electronic scanning radar and what are the advantages compared to the mechanical scanning radar, right? So it will allow us to reduce the error and which cause the beam steering error to reduce to 0, and we are able to detect multiple targets with the help of electronic scanning radar. Chapter number 7, that is the navigation. So what do you mean by navigation? We are going to direct a target from one point to another point, and it is known as the navigation. So what are the types of navigation? There are 4 types of navigation that we are going to study in chapter number 7. Chapter number 8, that is radio direction findings. So in this chapter, we will find that how to find the target in presence of different clutters. Alright? At which frequency? Chapter number 9, that is radio ranges. So in this radio ranges, we are able to find how my target is far from the radar at low frequency, medium frequency, and at the higher frequency. Chapter number 10, that is the hyperbolic system of navigation. Now what do you mean by hyperbolic system? Hyperbolic system means my receiver is able to receive the signal from the multiple transmitter. That is known as the hyperbolic system. And there are different types of hyperbolic system like LoRaWAN, TACAN, DECA. So the types of navigation system, hyperbolic navigation system that we are going to study in chapter number 10. Chapter number 11, that is aids to approach and landing. That is how we are able to land an aircraft safely with different methods that we are going to study in unit number 11. And the last chapter, that is the recent trends in satellite navigation. So we are going to study the applications of radar, like in the satellite communication. Apart from that, GPS, Navic receiver, its block diagram, everything that we are going to study in unit number 12. So, today we are going to start chapter number 1, that is the introduction. Right? So in this chapter, we are going to study what is the objective, the introduction of radar, that means a full form of radar, what are the applications of radar and where it is used. It can be used at what, at which frequency radar is going to be operated. The term, that is a radar range, what does it mean, and how to derive its equation, that means a range calculation of any radar. Now, the objective of studying this chapter is, first, we are going to calculate a range of pulse radar, right? The first of all, what do you mean by pulse radar? So, pulse radar means we are going to transmit the signal from antenna to the target in the form of pulse, continuous pulse, right? Second, we are going to calculate and interpret the minimum range, unambiguous range, and the range resolution, right? So, what do you mean by minimum range, unambiguous range, and the range resolution that we are going to study? Third, we are going to derive the radar range equation, right? And the fourth, we are going to solve it for the maximum radar range using the simplified radar range equation. We are going to relate the maximum radar range with the simplified radar range equation. Alright? Let us start with the introduction of radar. As you can see from over here is Heinrich Hertz, that was a German physicist that proved in the late 1880s that the electromagnetic waves can be generated by a sparks from an oscillator. And then we know that oscillator is the continuous signal at a fixed frequency. Right? That means he had noted that it is of no use because as electromagnetic wave is generated with the help of spark, there is no use of it. Okay? But the Guglielmo Marconi, the Indian electrical engineer, in the 1895 has proved that if electromagnetic signal we are able to send from a point to a several kilometer away. That means we are able to establish the communication. So in 1899, we are able to sense the communication between Britain and France, right? And the Marconi has won the Nobel Prize in the physics. Now, what is a full form of radar? So, a radar is nothing but radio detection and ranging. So, what do you mean by radar? So, radar is nothing but an electromagnetic device which are regarded to be a powerful electronic eye. That means we are going to locate and detect a target in presence of fixed target. It can be a moving target or a fixed target, right? So we can see that it is also an electromagnetic sensor. So what is done by radar? We can say that a radar can see the objects which is hidden anywhere in the globe, or we can say a planet which accepts some special cases like a low altitude. That altitude means what? The height from the surface of the earth. The shape changing the reflection direction and which kind of fiber material that we are going to use. So these three are the spatial parameter that we can say that the radar can able to see the objects or the target which is hidden anywhere in global. as we can see that the application of radar in war. So the World War I, which was found with eyes and ears, there is no such things as a radar, right? So before World War II, the Germany had a radio measuring device in which the numbers which are outplaced the areas along the sophistication. So by late 1940s, Germany faced a development of radar systems which are going to be credited at the short war, right? But that radar was used at a maximum of 30 megahertz of frequency range. So we can say that the application of radar is the first is for military purpose, weather forecasting, to guide an aircraft or to land safely aircraft, that means airport controlling, navigation that I have already told you, to detect and measure the objects under the ground, or we can say under the earth, that means mining of minerals, and to indicate the speed of automobiles, cricket and tennis ball, that is the application of global positioning system, that is a GPS, right? So these are the applications of radar. Now at which frequency radar is going to be operated? We can say that the operating frequency of the radar is most commonly 1 gigahertz to 17 gigahertz. Over here, the frequency range is available starting from hertz to megahertz, gigahertz, terahertz, likewise. So this is the frequency range and this is the wavelength in meter. Alright? So we can say that the lambda is equals to C by F, as the wavelength is inversely proportional to the frequency. So as the frequency is going to increase, the lambda is also going to decrease, because both are inversely proportional. So we can say that the radar is going to be operated at the gigahertz frequency. So my wavelength is going to reduce. Alright? So the most commonly used radars which operating at the frequency of 1000 megahertz to 70 gigahertz. So the red bar which shows the operating frequency of radar. Alright? And we can say that the ranges can be between 400 megahertz to 20 gigahertz. Alright?